Hi everyone, we're going to evaluate the improper integral from negative infinity to infinity of dx divided by e to the power of x plus e to the power of negative x. It has this form, so we're going to use part 3, and we're going to have to integrate our function here because we're going to use limits. I want to go ahead and integrate this very quickly before we start with the evaluation. So if I just had a normal indefinite integral, and if I had 1 divided by e to the x power plus e to the negative x power dx, what I would do is multiply the numerator and the denominator by e to the x. Again, this is dx. And to simplify this, this is my integral. I would get e to the x, and then when you distribute this e to the x, you're going to e to the 2x plus, when you multiply these two, that's e to the negative x times e to the x equals e to the 0, so that's plus 1. Now I'm going to let t equal e to the x, so dt equals e to the x dx. So substituting in my t, I'm going to get this equals t divided by t squared plus 1. And this is going to equal inverse tan of t plus c. So I wanted you just to know what the integration is on this before we start. So now that we have that, we can continue on with what we're going to do. So let's do that. We're going to take our integral and rewrite it in this format with limits. So we're going to write this as the limit as b approaches, we're starting negative infinity, and then we're going from b to 0 of dx divided by e to the x plus e to the power of negative x. All right, plus, then you take the limit as b approaches infinity, so we're doing the upper limit now, and then that can be rewritten as b 0 to b dx divided by e to the power of x plus e to the negative x power. All right, so now let's integrate, and we get the limit as b approaches negative infinity, and this is going to be inverse tan of e to the x. Before we had inverse tan of t plus c, and when you substitute back in the t, you get e to the x. I forgot to do that. All right, so once we have this, we're evaluating this from b to 0, and then we have plus the limit as b approaches infinity of inverse tan of e to the x, and this is from 0 to b. Now let's look at our limits. When you plug in 0, we start with this. This is going to be 1. E to the 0 is 1. So when I do the limit here, I'm going to get tan, inverse tan of 1. Then you do the subtraction, and when you're going to plug in the b, so that would be inverse tan of e to the b power. But as b goes to negative, this is going to be, this is just going to go to inverse tan of 0. So if you're going to the negative part, this would be like e to negative b. And so that would give you 0. So this is going to be a 0 there. All right. Now let's do this side. For infinity, positive infinity, we're just going to get the limit as b approaches infinity of inverse tan of e to the power of b minus inverse tan. And again, when you plug in 0, you're going to get 1. All right, now looking at this, this gives you pi divided by 4 minus, this is 0, okay, plus, now when b goes off to infinity for this, this is going to make this get the limit of e getting larger and larger here. That's going to go to pi divided by 2. All right, so there's that. And then minus, we already know this is pi divided by 4. So what happens is your pi divided by 4's cancel, and you have the zeros cancel. So all we're left with is pi divided by 2, and that's going to be your final answer. Thank you. Have a nice day. Bye-bye.